All right, we're going to take a look at a few of these examples, preparing for the test. We're skipping 1 and 2. It shows up on your sheet, but we won't be completing the square. We'll be jumping straight into the solving by factoring. One thing we want to keep in mind whenever we're solving by factoring is to check for a GCF, greatest common factor. And that's what we have on question number 3. Notice we have 2, 8, and 10. All of these numbers are all even numbers. So if I wanted to start this question off, I could start this question off by dividing everything by 2. Notice I didn't say factor because in this case we are solving. So when we're solving, we're allowed to just divide an amount out like I just did. And when we do this, you see we end up with x squared plus 4x minus 5. And remember, when we're solving by factoring, what we're trying to do is get the factors of 5 that can become 4. Anytime we have a consecutive number like that, 1 is going to be one of the factors. And in this case, we would factor this down to x plus 5 times x minus 1. And then we set each of these parentheses equal to 0. Which means my solutions would be x equal to negative 5 and x equal to positive 1. You can always check this answer by graphing to see if it does actually cross where we say it's going to cross. You could have also gotten this with a quadratic formula, but that would not have been nearly as quick as we just did. All right, next one, we'll take a look at question number 4. We're going to breeze through these quickly. We won't necessarily watch all of these, but you can go back and watch them on your own. Remember, we need the factors of the C value, 15, that can become the B value, 2. So 15 is 1 times 15, 2 is no, 3 times 5. So the values that can become 2 are 3 and 5. So we're going to split the x squared to each of the first parentheses here. And we're going to split the 15 up as a 5 and a 3. And we need the value that's going to add up to be a positive 2. So the 5 is going to have to be the one that's positive. The 3 will be the one that's negative. We'll take each of these parentheses, each of these factors, and set them equal to 0, leaving us with solutions at negative 5 and also a solution at positive 3. All right, question number 5. We first notice that it is not in standard form. So the first thing we need to do is to move the 5x over to join our remaining terms, other terms. So we'll just subtract the 5n from both sides. Rewriting this, we would end up with 3n squared minus 5n minus 12. I would like to factor out a GCF, but I do not have one. 3 is a prime number, and 3 goes into the 12, but it does not go into the 5n. So what we're going to have in this particular question is the AC method. So the way we find the AC method, we call it the AC method because we're going to multiply A times C. That would be negative 36. And those factors of 36 are the ones we're going to use to try to get 5. So 36 times 1 doesn't work, times 2 times 18, too big. 3 times 12, that doesn't work. And then our winning answer, 4 times 9. 4 times 9 does equal 36. So we're going to replace the 5 with an equivalent amount. That amount is going to be negative 9n and positive 4n. So what we're doing is we're replacing 5n with the equivalency, which is 9n plus 4n. We carry everything down just like you see. We have 4 terms. Anytime we have 4 terms, we need to be thinking about factoring by grouping, which is what we'll do. As we do this, we recognize 3 and 9 both have a factor of 3. They both have an n value. So this is going to factor down to 3n times n minus 3. Keep in mind as you're doing these that these values right here will match the value on the other side. Or we pick the wrong factors. We're going to carry down our plus sign. We can't factor a 4 from both of these, and it leaves us with the n minus 3, just as anticipated. These two values are being multiplied by the same thing, so we can put them together and multiply once. So now we factored this thing down, and this is what we have. N minus 3 is the solution, n equal to 3. There's one solution. On the other one, I'm going to go ahead and set up a little mini equation here, just to make sure I don't mess it up. I subtract the 4 from both sides, so that would give me a negative 4. I divide by 3, and then I get my second answer, which is n equals negative 4/3. And again, I know that's a little quick, but go back and watch the videos, see what you think. Put them in a slower motion if you want. Go back and rewind it. So moving on to question number 6. Again, I'm going to try to get through all of these. We obviously won't be able to get through all of them in class, but you should be able to go back and look at any of these you want. So again, here we go. We've got an a value again that is not 1. Ideally, it would be nice if I could factor out a GCF, but I do not have one, so I don't have that option. So we're going to use the AC method again. 5 times 7 is 35. I need the factors of 35 that can become 12. Well, 35 doesn't have many. 1 times 35. 2, 3, 4, 5, and 7. So we need the factors of 5 and 7 to replace our 12. Doesn't matter which order we put these in. So if I have a choice, I would rather put the 7 with the 7. So I'm going to put the 7k on the right side because that would match it up with the other 7, and negative 5k on the left side. And again, those add up to be 12k. So I haven't done any adding or subtracting. Haven't changed anything. And then the 7 and the 5 drop. And so does the 0. So now we're down to 4 terms. Anytime we have 4 terms, we definitely want to be factoring by grouping. So I'm going to factor out a 5k from this, leaving me with a k minus 1. And on the other side, I can factor out a negative 7. I know they don't have both negative signs, but if I don't factor out a negative 7, this k would be k plus 1. Negative k plus 1, actually. So I want these to match. The only way I can do that is to factor out a negative k. So we have 5k minus 7 times k minus 1. One solution is k equal to 1. The other solution, here's the way I like to look at it when it's these binomials. The opposite of this, 7, divided by that, 5. You can also set that up to 0, just like I did earlier, and you can solve from there. You don't even need the instructions that we see on this. Solve each equation by taking the square root. Anytime you notice that the b value is gone, and remember the b value, if I got everything to one side, it would be a, there is no x value. There are just 2 other constant values. So the b value is gone. Anytime you have that, what you really have is an equation with one variable. Anytime you have an equation with one variable, just solve for that variable. So I'm going to add the 9 to the other side. This would give me a negative 36. I'm going to then divide by 8. Got a little bit of a problem about to happen here. So we have 36 divided by 8, and it's negative. So we're about to get an imaginary answer, and that's not a problem. I'm actually not going to simplify this, even though it does. And the reason why I don't want to simplify this is because of the, because of the 36 having a perfect root. If you do, it's okay. Take an extra few steps, but that's not a problem. So here we go. X squared equals, this is going to be plus or minus, and I'm going to go ahead and kick the I out there. Because when we take the square root of a negative number, that means we have an imaginary solution. Two of them, actually. That's why we have the plus or minus. Square root of 36 is 6. The square root of 8, there is no exact square root on that one, so we're going to leave it like that. Now, that's not accurate as of now, because the square root of 8 can be simplified. Remember, if we go back to the 8 and we break it down to prime factors, anything that pairs out gets out. So we've got a pair of 2's here. So what I end up with is x equals the plus or minus I 6 over 2 square root 2. The 6 and the 3 can cancel because the 6 and the 2, can cancel because those are both constant values. So getting a little more simplified, still got a couple of steps to go on this one. We end up with x equals plus and minus I 3 over square root 2. Now I've got a little trick I call bump and keep. What I mean by bump and keep is I'm going to bump the square root of 2 up to join the 3 and keep the radicand right just like that. So the I is going to come back and join, and so is the plus and minus. So that's what this answer would be. Two imaginary solutions, the positive negative version of this. And that doesn't simplify anymore, so we are good. Let's look at question number 8. Again, it's missing the b value, so we're able to just take the square root. We add 6 to both sides, which gives me 25. Next thing I want to do is divide by 9. Again, I'm not going to simplify that because my next step is to take a square root. And both of these terms actually have perfect roots. So by simplifying it, I'm going to actually make things worse for myself. Just do a little evaluation on that first. The square root of 25 is 5. The square root of 9 is 3. So we have that solution, plus and minus 5 square, plus and minus 5/3. We should actually see crossings on this one because those are not imaginary answers. All right, next one. This is what most of you are probably going to do tomorrow, and that's fine. It's the quadratic formula. Quadratic formula is the safest route. I'm going to write this down here. Remember, it's opposite b plus and minus the square root of the discriminant. You'll use that a little bit later, which is b squared minus 4 times a times c, divided by 2 times a. Let me just give you a little disclaimer here. Put that b in parentheses. Just get in the habit of doing that, because if it's a negative number, it's going to change to positive. And if you don't make that acknowledgement, you're probably going to make a mistake. So only on the first one am I going to do this. I'm going to name the values. A is 10, B is also 10, and then C is 7. So I'm going to plug this into my equation, formula, opposite of B, plus and minus the square root of, here comes the parentheses, even though this one doesn't technically need it, minus 4 times A times C, all divided by all divided by 2a. You might could do some of that math in your head, kind of like that one. 2 times 10, of course, is 20. So we end up with negative 10 over 20. And I like to personally put this in my calculator and see if this simplifies. So you can put all that in your calculator right there. I'm going to do the math just over to the side because what we end up with is 10 squared, 100, minus, if we do 4 times 7, that's 28, times 10 is 280. So we got a little bit of a problem here because we end up with negative 180. The discriminant is negative 180, which means we're about to get an imaginary solution. So we're going to go over to the side here and break down 180, see how this breaks down. Don't forget the y equals 180 divided by x squared trick that I showed you that will reduce the radical. But I'm going to go ahead and work this one out for you. This is 2 and 2, so anything that pairs out gets out. So that means a 3 gets out, a pair of 2s get out, and a 5 is left on the inside. So what this is, the square root of 180, excuse me, is 6 square root 5. Remember also that this is an imaginary solution, so it's going to be 6i square root 5 over 20. This one actually reduces because 10, 6, and 20 are all even numbers. So this is going to break down to 3i square root 5 over 10. Notice the 5 under the radical did not reduce. We can't reduce radicals with non-radicals. That's why it's staying just where it is. All right, we're going to do question number 11. I'll probably leave number 10 alone. Let's take a look at question number 11. A value is 3, B value is negative 1, C value is 9. So we'll put this in our formula. And I'm going to do this some of this work in my head as we go on because this is easy to recognize. B is negative 1, so the opposite of B is 1. Plus and minus the square root of B squared. Well, negative 1 squared is 1. Minus 4 times A times C, which is 9. All divided by 2 times A. Well, A is 3. 2 times 3 is 6. So we have 1 plus and minus the square root of, it's the square root of 1 minus 108. 4 times 3 times 9 is 108. So here's another imaginary solution. We're about to take the square root of a negative number. The discriminant is 107. So 107 is a prime number. So all I can kick out is the I. 107 over 6. On these questions, what we're looking for is the discriminant. The discriminant, excuse me, is b squared minus 4 times a times c. Remember this about the discriminant. If we end up with a positive number, that is 2 real solutions. If we end up with a number 0, that is 1 real solution. That's the one that's going to graze the axis and then go right back up. And if we have a negative discriminant, it is 2 imaginary solutions. 2 imaginary solutions. So in order to use this, what we have to do is have it in standard form, which we can see that number 12 is clearly not in standard form. The 2 should be on the other side. So when I subtract the 2 over to join, I end up with 4r plus 4. So I'm going to just put this into the discriminant. Discriminant is b squared minus 4 times a times c. So my discriminant ends up being 16 minus 16 for a total of 0. Now, this is where people get confused. 0 means nothing. It is the discriminant, but it means nothing as far as solutions. All it's telling us is that we have one real solution. And it is not 0, by the way. Looking at question number 3, we've got to move our 4 to the other side. So 4 is moving to join. Add it, becomes 10. So again, b squared, use that parentheses, minus 4 times a times c. Parentheses makes this stay positive a1, excuse me. So we end up with 81 minus 80. 81 minus 80 is 1. That is a positive number, falls in this category. So what we have is 2 real solutions. And that's all the discriminant does for you, is it tells you how many solutions you have. And then the last one, we're going to move the 9 over. This one's an interesting one, because when we move the 9 over, we have negative 7. Well, we have an a value of negative 10. We have a c value of negative 7. So where's our b value? Well, this actually works out really well for us because the b value is 0. That's why it's not there. So we end up with 0 squared minus 4 times a, which is negative 10, times c, which is negative 7. So we have negative 4 times negative 10, which is negative 40, times another negative, or excuse me, that should be positive 40, times negative 7 is negative 280. And again, negative 280 doesn't mean anything for solving. It just tells us how many solutions we have. Since this is negative, we have no reals, but 2 imaginary solutions. All right, on these 2 questions, we want you to notice it says find the axis of symmetry, the y-intercept, and solutions. Then sketch the graph. There is a formula for axis of symmetry that I did not talk to you much about. You're welcome to use it, but it's opposite b over 2a. I personally don't like to use this because I like to graph. And whenever I graph, I have all the points that I need. One thing we need to know as well, y-intercept is really easy. If it's in standard form, it's the constant value. It's the constant value, which is negative 1. But let's try this opposite b, what's negative 4, over 2 times a, which is also negative 2. So we end up with this negative 4 divided by negative 4, which is 1. So our axis of symmetry is positive 1. So if I were to draw my axis of symmetry, that's where my vertex is going to fall. The way that I find my vertex is I just simply plug in 1 to the equation. The equation up here at the top. So it's negative 2 times 1 squared plus 4 times 1 minus 1. Make sure you do the squared first. 1 squared is 1 times negative 2 is negative 2. So negative 2 plus 4 minus 1. So negative 2 plus 4 is 2, minus 1 is back to 1. So my vertex is at 1, 1. Which means I will have a point here as well. I want you to notice this as well. We're going to use some of our transformation cheats. I say cheats, they're not really cheats. Remember how we went over 1? It's supposed to go down 1, but it actually went 2. It went twice as much as it should have. Well, we can kind of do this. If I go over 2, we should go down 4 units. Because 2 squared is 4. But since we're going double that, we're going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8, which would put us here. And since we have a symmetry line, this is 2 units away here, this is 2 units away here. So we are able to sketch this graph without any, that's too far over, sorry. Looks a little funny. Should be sitting right here. 2 units from the axis, just like the other one is. So there we have it. On the second one, we have a y-intercept of 2. We do not have an axis of symmetry. Again, please graph. If you feel comfortable graphing, graph. So we have opposite b over 2 times a. A is 3. So now we have -6 divided by +6. So we have an axis of symmetry at x equal to -1 on this one. So we have an axis of symmetry -1. That's also where our vertex is. We can plug this in just like we did with the other one. We're going to plug in -1. As our value. And if you're concerned that this is not how we did it before, that's okay. Graph it. Graphing's a simple concept. You're welcome to use it. Again, use your powers first. -1 should get squared first, which is 1. Times 3 is 3. 6 times -1 is -6. Plus 2. These two make 5. 5 minus 6 is -1. So this one's at -1. -1. -1, sorry. And remember, we have axis of symmetry. Just in a different color. So if this point is here, there's another one right there. Same thing. When we go over 1, we're supposed to go up 1. But we went up triple that because our A value, our vertical stretch, is times 3. So if we go over by 2, remember 2 should go up 4, but we are going 3 times as fast. So 3 times 4 is up 12 units from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And axis of symmetry means there would be one here as well. So we have a very thin parabola that popped up here for us. Just like that. We named our axis of symmetry. We named our vertex. Actually, we didn't name our vertex. We found it, but we didn't name it. Our vertex is there. And the vertex over here was at 1, 1. And then we sketched the graph. And our solutions would be where it crosses the x-axis. All right, on this one, we're going to try to build off of what we did with the Kahoots yesterday. See what we can remember. We're going to describe the transformations and then sketch them. Well, let's first recognize what we see. We have something happening inside of a parentheses, which means we have something horizontal. We have something happening outside of a parentheses, which means we have something vertical. We have something else happening outside of a parentheses, which is vertical. And then the one that all of us might overlook is this, the negative sign. So we actually have 3 things happen vertically. Let's go ahead and take care of the negative sign first of all. This is a vertical reflection. A negative sign on the outside of a parentheses is a vertical reflection. So our thing is going to be looking and running upside down. All right, now let's talk about the other things. Inside of the parentheses, we have a horizontal. It is a shift because of the adding or subtracting sign. I'm going to just take care of the words, and we'll talk about the directions in just a second. The vertical on the outside is also a shift because it is a plus sign. And then the last thing was the 2 in front. Notice I didn't say negative 2. 2, and it is a stretch. So we have all this going on for us right now. So the horizontal shift, remember the horizontal shift is always inverse of what you would think. So that feels like I should be going left 2, but it's not. I'm going to go right 2 units. The vertical shift does do what it's supposed to. So plus 2 is actually up 2 units. And the horizontal stretch is by a factor of 2. So we got a lot going on here. One thing I want to talk about when we graph this thing is we have the vertex. That's why it's called vertex form. Remember, the vertex is the value in front here, which in this case is 2, and the value on the outside, which is also 2. The negative 2 has nothing to do with this, so here we have a vertex of this. Notice I said nothing about the y-intercept of 2 because this is not in standard form, so we can't do that. What we can do, though, is keep in mind that little targeting system I always talk about should be here, 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 naturally, but ours is not natural. Ours has been stretched by a factor of 2. So when we went over 1, instead of going down 1, what we're going to end up doing is going down 2. So we'll have a point here as well. On the same regard, when we go over 2 on a quadratic formula, we should go down 1, 2, 3, 4. We should be here and here. But we're not doing the traditional thing. We're doing double that. That's what a stretch is. It makes it double what it normally does. So instead of going down 1, 2, 3, 4, we will go down 8, 4, 5, 6, 7, 8. And then we will have the same reflection on the other side. So we were able to name all of these things and sketch a graph without going to the calculator. I'm not telling you you can't go to the calculator, but just showing you that we don't need it. 17 was a lot harder than 18, so let's just look at 18. It only has 2 transformations. One of them is inside of a parentheses, which makes it horizontal. One of them is outside, which makes it vertical. And they are both plus or minus signs, so they're both shifts. The vertical shift does what it's supposed to, so it's going to vertically shift down 4 units. The horizontal always does the inverse, so minus 1 seems like it should be left, but it's in fact right 1. And while we're at it, let's name that vertex. Vertex is at 1, negative 4. 1, negative 4. So we don't have a transformation of the stretch or compression. So the normal targeting system is actually going to work. When we go up 1, we should go over 1 and we would have a point. We should go back 1 and have another point. When we go over 2, 1, 2, we will need to go up 4 because 2 squared is 4. 1, 2, 3, 4, and there's our solution. Not that they asked, but we know. And then there's going to be the reflection of that, because remember, the vertex is at the axis of symmetry. So if it's 2 units from here, it's 2 units from there. There we have our graph without using a calculator. I'm going to try to stay away from the calculator on this one as much as I can as well. I'm probably not going to be able to do such a great job, but we'll see. Again, I'm not trying to tell you not to use a calculator. I'm just showing you that it does not need to happen. All right, first off, it says the height of a rocket is determined by this function. Where t is the height of the rocket in feet after h of t, excuse me, is the height of the rocket and feet after t seconds. It's always a good idea when you're dealing with word problems to label what everything means. All right, so what is the initial height of the rocket? Well, remember we talked about this before. Your initial height is where it was when no time goes by. So if I plugged in 0 for t, that would go away. Plugged in 0 for t, that would go away. So my initial height is 54. So in other words, your initial height is your constant value. So we're going to just call this 54 feet. What is the height of the rocket after 3 seconds? Well, this one's going to be a little rougher without the calculator because we got a lot going on, but let's see what we got. Remember, seconds stood for t. So all they're asking me to do here is take my formula and replace all of my t's with the number 3. Again, make sure order of operations says that powers happen before multiplication. So the first thing I should do here is 3 squared, which is 9, plus 63 plus 54. Well, 63 and 54 make 117. I'm going to go ahead and take care of that. Negative 3 times 27. Negative 3 times 9 is negative 27. Negative 27 plus 117 is 90 feet. So what was I talking about again? Oh yeah, the height of the rocket. So what is the height of the rocket after 3 seconds? 90 feet. 90 feet. What is the maximum height of the rocket? Well, our rocket's going to take off. We have no idea how long it's in the air. We know at 3 seconds. We don't know if 3 seconds is past the vertex or in front of the vertex or what it is, but we know that that's all the information we have. We also know that it starts at 54. So what we're going to do is find the axis of symmetry. Here's that formula. Opposite B over 2 times A. So we end up with negative 21 being divided by negative 6. They both have factors of 3. So what that means is our axis of symmetry is at 7/2 or 3.5 seconds. At 3.5 seconds, this rocket is going to be at its maximum height. Now, I am going to have to revert to the calculator on this because we are running into some difficult numbers here. But what I'm going to do is take my equation, negative 3 times x squared plus 21 times x plus 54. And the x that we're interested in right now is 3.5. Sorry, I cannot do 3.5 squared in my head, but we'll take this to a calculator and bring back a number. All right, my calculator tells me that this height is 90.75. So that would be our maximum height. And how long in seconds until the rocket hits the ground? Now, if this rocket would have been shot from the ground, it would be 7 seconds, because if it took 3.5 seconds for it to get to the highest point, it's going to take 3.5 seconds to go back to the ground. But this one started in the air. Again, I'm going to go back to my calculator and take a look. I may bring back a picture and let you see what I'm looking at. So here's what I came back with. you look closely here, really closely, that this has an x value at 9. So we're crossing at 9 here. What that means is how many seconds does it take the rocket to hit the ground? 9 seconds. And always answer back what they asked. What is the height of the rocket? The height of the rocket's 50 feet. This one said how many seconds? Well, make sure you give it to them in seconds. So 9 seconds, this rocket's back on the ground. All right, in this one, we're going to go straight to the grapher on this. I've already got these planned. We'll throw them in, but it says a ball is thrown in the air modeled by this function. This has not been thrown on our planet because remember, on our planet, everything falls at negative 16 feet per second squared. So this is thrown on some other planet from a height of 6, where b of x is the height of the ball, feet per second x. All right, so what we're going to do, what's the initial height? Well, we know this is the initial height is 6 feet. That's the constant value. How many seconds does it take the ball to hit the ground? Well, I'm going to go ahead and pull up my graph and let you take a look. So here we can see this ball hits an apex somewhere in this range right up here between 0 and 2. Not sure exactly what I gauged for because it says how long till the ball hits the ground. The ball is hitting the ground right there. That is an x value. When I put this in, what it tells me is I have an x value when y is 3. So what we have here is it takes 3 seconds for the ball to hit the ground. What's the height of the ball after 1 second? Well, in 1 second we could plug in 1, or we could just look at our table and see what the value of 1 is. So we see the value of 1 is 8. So what is the height of the ball after 1 second? The height of the ball after 1 second is 8 feet. And it says, what is the maximum height the ball has reached? Now, I did go to my calculator and plug this in, but I want to remind you that anytime the table starts pairing out like this one does, 6 and 6 on either side, if you were to move up to this -1, it would actually be 0 to match this one. The one that doesn't match is the vertex. So what is the maximum height this would reach? The maximum height is actually at 1 second. So the maximum height is 8 feet. All right, question number 21. It says a farmer purchased 250 feet of fencing of a building to build a rectangular pig pen. The maximum rectangular area that she can build with is 200 feet of fencing. So I'm going to show you guys how we are going to do this correctly, and then I'm going to let you in on a little secret afterwards. Because once you have this secret, you're probably not going to listen to anything else. So let's go ahead and draw this pen that they want to draw. It says rectangular pen. So what we have is 240 feet of fencing. Now, a rectangular fencing is 4 sides, and we don't know what those sides are. Here's what we do know, though. Whatever this side is, if this side is x, let's just say, if it's rectangular, that would mean this side is x. Whatever those are, they would be the same amount. Now, the top and the bottom are going to be what's left of that. Because remember, we have 240 feet of fencing, which means we've used all of the stuff for the sides. So the remaining fencing we're going to have is the 240 fence minus those 2 x's that we don't know. We don't know what these are, but we've got 2 of them, so we have to subtract that away from the fence that we've already used. Now, there are 2 sides to this fence, and they're equal sides. So the way we find what each one is, we have to divide this by 2. Half of it will be up here, so half of 240 minus 2x, and the other half of 240 minus 2x goes here. So this is the formula that we've created to find the area of this fencing. X times 120x by x. Now, the area is length times width. Many of you have told me this already this year. So if I'm going to find the area, it is the length times the width. What I can do with this formula, and I can put it in my calculator just as it reads. I don't need to distribute this out or anything like that. All I have to do is put this in my calculator. So you can see I've taken this to my calculator, and what I did was I put in y equals this. I didn't even calculate those. I let my calculator worry about that. And it gave me this graph. I also took the time to go ahead and calculate the maximum. So the maximum amount of fencing, is when x is equal to 60. And the amount of area that we will have, because remember the question said, what is the maximum rectangular area? Well, the rectangular area would be 3,600 square feet. All right, here's the secret. Remember this tomorrow. Anytime you're trying to maximize an area with a four-sided figure, it's always a square. It is always a square. It is always the maximum area that you can have with these things. So we could have made this real short and sweet. Since there's 200 feet of fencing and a square is the best way, that means all four sides are the same length. So 240 divided by 4 is 60 square feet. And we could have calculated 60 times 60 is 3,600. I know you wish I would have showed you that from the beginning, but you wouldn't have listened to any of this stuff. But moving forward, anytime you're trying to get a maximum area with a four-sided figure, the answer is square. It is always the best shape. All right, since I already gave you the secret of the square, what we're going to do now is we're going to kind of build off of that. So this one says lifeguard has a rope, has to rope off a rectangular area along a straight beach for swimming. The lifeguard bought 320 feet of rope, and he ropes off 3 sides of the swimming hole, with the fourth side being the beach. So here's what he's doing. He's got a rope here, 1, 2, 3. And the fourth side is the ocean. What's the maximum rectangular area? Well, if you listen on the last video, I told you the maximum area we can have is a square if all 4 sides are the same. Boom, boom, boom. Just bear with me, listen carefully, because if you get this, this is really nice and easy. So what we're going to do, instead of taking our little square like we have here, we're going to figure out what that is. We divide by 4. That would mean the squares would be, we'd be best off if we had 80, 80, 80, and 80. But we don't need this 80 right here, because it is the ocean. And the more ocean that we use, the better we use. So we're going to try to keep our square shape, but what we're going to do is we're going to take this segment of 80 and give it to the other side. These two on the outside are still going to be 80, but the side over here is going to be 160. This is the way we maximize our area if we have the other side. You can sit there and construct a formula. That is fine. You're welcome to do that. Our formula would be x and 320 minus 2x. And since we are talking about area, it would be 320 minus 2x times x. That would be the area. Go ahead and put that in your calculator. You can check it out. But what I'm telling you is this. The maximum shape you're going to make is to still make your square, but take the side away and add it to the opposite. So all I need to maximize my area here is to multiply 80 times 160. When you multiply 80 times 160, what you get is 12,600 square feet. Oops, square feet. Nice little trick. Anytime you're trying to maximize four-sided figure, it is a square. If you could make any shape, the maximum area you can get out of things is a circle. Now, it's hard to construct a circle with fencing, but that is accurate.